Hello folks, so in this video we are going to discuss process scheduling as part of operating system coursework. Um, so as you are already aware, process scheduling can be done in two ways, broadly classified as non-preemptive and preemptive techniques. So under non-preemptive, you have FCFS, SJF and priority, and preemptive techniques we have SRTF, priority and round robin. So when it comes to FCFS, we call it as first come first serve, FCFS, and SJF stands for shortest job first. And under preemptive you have SRTF, which is actually a preemptive version of SJF. So it is called shortest remaining time first. And then you have priority and round robin in preemptive as well. And round robin usually works with the help of uh, time quantum, so which we'll be discussing in a little while. Now let's first try to understand the non-preemptive techniques initially. In order to understand these techniques, we will try to take a sample exercise problem here, and accordingly we'll try to move forward, right? So here is a small numerical that we'll try to take into account. So let's say that you are given 5 processes here with their corresponding burst times. BT here is for burst time, and then arrival times are also given to you, and the priorities of each process are also given to you. So we are taking 5 processes for our understanding here. So each of these 5 processes have their burst times here 10, 7, 6, 1, 5, and also their arrival times are also mentioned here, as you are able to see, 0, 3, 4, 12, 18, and also the priorities 2, 1, 2, 1, 1. Now coming to the priorities, we will take a smaller number as a higher priority here. I repeat again, a smaller number indicates higher priority. So in this case, suppose if we compare P1 and P2, P2 has 1, so P2 has a higher priority compared to P1. Now anyway, we'll be discussing that when we come to the priority technique as such. Now let's first start with the non-preemptive. Like I said, let's take FCFS. Now each of these techniques, for us to understand, we will take help of something called a Gantt chart. So Gantt chart is a small tool used for scheduling this process one after the other according to their arrival times or according to their priorities. We'll be seeing that in a little while now. So let's first start with, let me, yeah, use this marker here. Right, okay. So let's first start with FCFS. So we will be discussing FCFS here. All right. Now let's take the help of a Gantt chart here. Right. Now Gantt chart usually starts at time 0. Okay. Now at time 0, if you are able to see here, P1 is the only process which is currently available for us to schedule. Just give me a minute. So let me copy this. All right. Right, okay. So P1 is the only process which is actually available at time 0. So P1 will obviously be scheduled. Now because this is a non-preemptive technique, FCFS comes under non-preemptive technique. Now non-preemptive is a case where when a process starts, it will continue to execute until it finishes off its burst time. Unlike the preemptive techniques where you are forcefully stopping or suspending a process temporarily and again restarting it or resuming it later. But unlike those preemptive, in non-preemptive is all about you're voluntarily allowing a process to continue its execution until it finishes. So at time 0, P1 has started as per the table given to you. So P1 has a burst time of 10, as you are able to see here. Okay. So P1 will continue to execute till 10. Right now at time, we are currently at time 10. So at time 10, P2 and P3 both have arrived, as you are able to see. P4 and P5 have not yet arrived because it's well above the current time. So in the current time, in the meantime, P2 and P3 have arrived, but P2 has a better arrival time. So P2 will be scheduled first, right? And P2 has a burst time of 7. So starting from 10, it will continue to execute till 17 because of the burst time. Now after P2, obviously P3 will be scheduled because that was next in line. So P3 has a burst time of 6. So P3 will continue to execute from 17 plus 6, that is 23. Okay, then followed by, now current time is 23. So in the meantime, as you are able to see, P4 and P5 have also arrived because of 12 and 18 here. So but P4 nevertheless is arrived first than P5. So P4 will be scheduled first here. And P4 has a burst time of 1. So it will continue till 24. And lastly, followed by the remaining process, P5 has burst time of 5. So this Gantt chart will stop at 29 here. Now just for your benefit here, just for you to remember whether your Gantt chart is correct or not, just as a verification. So you can simply add up all the burst times here, right? So you would see that it sums up to 29 actually. And that will be the last point in your Gantt chart as well. So in case for some reason you are not able to, get that 29 or whatever the number is according to the total here, it is kind of intervention that okay, you have done something wrong. So maybe that's just a thing that you can remember. Okay, now that we have a Gantt chart here, what is the next thing that we are supposed to do? Obviously compute the wait time and turnaround time. Now how do you compute the wait time? So wait time can be computed using the simple formula start time minus the arrival time. Okay, so for each and every process here, P1, P2, P3, P4 and P5, we will now try to compute the wait times. So obviously from the Gantt chart, you are able to see that P1 has started at 0. Okay, so P1 started at 0. So start time minus the arrival time, which is 0. P1 arrived at 0, right? Okay, then followed by P2. So P2 started at 10. So 10 minus the arrival time, which is 3, equal to 7. Then followed by P3 started at 17. So 17 minus the corresponding arrival time is 4, 13. Followed by P4 started at 23. 23 minus the arrival time 12, equal to 11. Followed by P5 started at 24 minus the arrival time 18, which is equal to 6. Now we need to compute the average wait time, which is simply sum of all this divided by the total number of processes. So that comes up to 0 plus 7 plus 13 plus 11 plus 6. That is 37 divided by 5 process. So 5. So the average would be obviously 7 point. So 5 and 35 and 4. Yeah, 7.4 is your average wait time. Okay. Now let's try to calculate the average turnaround time. Now what is turnaround time? Turnaround time is simply the yeah, okay, let me quickly change the brush here. Okay, yep, right. So turnaround time can be computed using another simple formula, completion time minus the arrival time. I'm sorry, touch screen here, so it's just okay. Yep, my mistake. Yeah, so that's the formula for turnaround time. So for each of these process P1, P2, P3, P4 and P5, we will now compute the turnaround times using the formula completion time minus the arrival time. Okay, so P1 has completed at 10 now. Okay, so 10 minus its arrival time, which is equal to 10. Now similarly P2 has completed at 17. 17 minus its arrival time as per the table is 3, so equal to 14. Then followed by 23 for P3 minus its arrival time is 4, is equal to 19. Then followed by P4, completion time is 24. So 24 minus its arrival time is 12, which is 12. Followed by P5, completed at 29. So 29 minus arrival time 18, which is equal to 11. So now the average turnaround time is obviously sum of all these values divided by 5, total number of processes. That would be, so 10 plus 14 plus 19 plus 12 plus 11 divided by 5. So that would be 24 plus 19, 43, 55. That is 66 divided by 5, which comes up to 13.2. Is that correct? Okay. So these are the average wait times and average turnaround times using FCFS technique. Okay. Right. Now let's get to another technique called SJF. So let me quickly copy this table again for your reference. Copy it. Right. Let's move to